6 years, and it's still worth reading every day, and you get something out of it. Today, Gary's going to be talking about his work on memory and aging, as well as some of the more recent studies he's done. In particular interest to this gathering is how technology is not only changing and altering our lives, but how it alters our brain. So please welcome Gary Small. Thank you.
Thanks, Dan. It's great to be here. What's that? Oh. I've got a lot of pressure today. Already Dan is testing my memory. How many years has that book been printed? And now we're working on the technology. Okay. So anyway, thank you, Dan, for that lovely introduction. This was actually a case of multitasking. You can see how distracting it can be when you're trying to focus on something. And we'll talk about that in a moment, about how we all tend to multitask, and we have the perception that we're getting more done, but actually we're faster, but sloppier. We're making more errors, regardless of the age. But I wanted to thank Dan for that lovely introduction. Thanks Susan for organizing this conference. Also thank the sponsors and thank all of you for coming today and hearing what I have to say, and also the other fantastic speakers and panels. Now, I'm going to talk about a number of things. I'm going to talk about aging, the aging brain. I'm going to talk about technology and kind of the interface of all those things. But to begin with, I just want to make some key points that I'm going to cover. And I'll start with the observation that all this technology is very personal. Certainly it's global. It's made our world very small. We can contact anyone, anytime throughout the world. But also we have a lot of feelings about our technology. And to demonstrate that point, I'd like to do just a brief experiment. This will be one of the few times I can do a study without having you fill out a 22-page form. So this is completely voluntary, but I'd like you to try to participate because the point will become more meaningful to you. Now, Susan a moment ago asked you to put your cell phones on buzz. Now, what I'd like you to do is turn your phone on, and as you turn it on and you hear the little jingle, whatever the sound is, note how it makes you feel, okay? Let's hear those sounds. It usually takes longer to find the phone than it does to turn it on. So probably as you hear that little sound, you feel good. You feel connected. I don't know, I didn't hear any sounds. People didn't turn their phones off like Susan asked them to. Yours, okay. You know, the vibrate always gets me. You put it down and it vibrates so loud, it's just like an earthquake. So I think I heard somebody turn it on. Very good. So it's usually, you know, you're connected. Now you can get that text, that email, whatever it is, and it makes you feel good. Okay, now, here's part 2 of the experiment. This is a little more challenging, and you can drop out of the experiment anytime. What I want you to do is swap your phone with a neighbor, preferably someone you don't know, and then ask yourself how it makes you feel, okay? Just hand it over. Come on, you can do it. So usually, I want you to know, I am a board-certified psychiatrist, so if anybody has a panic attack, I know exactly what to do. But this, you know, I recently got a new iPhone, and my brother-in-law was looking, and then he slammed it on the table. It made me very upset, you know. So take your phone back so people don't freak out completely. And then, so that's good. We feel a little less anxious. But now here's the last part of the experiment, and one of the themes of this talk, and what I'd like you to do, if you can handle it, don't put it on buzz, just turn it off, okay? And just kind of take some time offline. It should relax you. Now, if you can't do that, that's okay, I understand. It's, there was a TV show, I think on CNBC this week, called Crackberries, about people who really can't put this stuff down. And it's really quite extraordinary. When I go around to college campuses, the professors can't get the students to stop texting during class. In fact, one professor told me that what she does, she gives them a 5-minute break halfway through the class. This is just extraordinary to me. So we're really quite connected to our technology. It's very personal. And it's also affecting our brains. So that's another big point. Besides the fact that it affects our emotions, it's clearly affecting brain neurocircuitry. Now, what do I mean by that? Well, if you look at how our brains work, they're very sensitive to the environment. Every sensory stimulation from moment to moment, whether you're looking at a computer, whether you're looking at a book, hopefully this book, or looking at a facial expression, there are physiological responses in the brain. Light comes into your eye, it hits the back of the eye, the retina. The information is transformed into little chemical packets, neurotransmissions that go across the connections between neurons, the synapses. And the brain is highly organized at birth. So we have these different brain regions that control different functions. So for example, the frontal lobe, the thinking brain, puts things together in a complex way. Visual cortex. Now what's remarkable is the brain is so light it weighs only 3 pounds, and yet there are billions and billions of these synaptic connections. So it's quite a complex organ, and it's very compact, and it's very specialized. So if you look at this experiment, these are experiments that have been done with PET scans, so they can look at brain function from moment to moment. And you can see in one experiment, they have the volunteer listen to a word, and you see the part of the brain that's activated. Then they have them look at the word, a different part. Here they speak the words, clearly a different part, and yet the word, it's the same word. So the content is the same, but the processing is different. You can see how different the neural response is. So you perceive an image or a sensation, you have an emotional reaction. It could be a repressed memory. You recognize someone from Woodstock. If you look really hard, you might see someone there. Or it could be an automatic response, a motor response, as a result of some kind of momentary mental stimulation. And these neural networks, they look here in this image, it looks like a plate of spaghetti, but trust me, it's much more intricate and much more involved. And we know that because of technology, because of these marvelous technologies that have been developed over the last several decades, where we can peer into the brain and measure almost anything that goes on through PET imaging, MRI, quantitative EEG, and you read about it all the time in the newspaper. fMRI scan is used as a lie detector test, or now we've pinpointed the emotional center of the brain, or now we know where love sits in the brain, and so forth. And we will probably eventually be able to measure almost any mental state, almost any emotion in the not too distant future. Another important point is our brains are very plastic, meaning that they are changeable from moment to moment. So you can think of a brain analogous to a computer, where you have basic programs built in. I showed there's an organizational structure at birth. There's plenty of room on the hard drive when we're born, and we still have these specialized macros or circuits that are shortcuts that help us operate things very quickly. Now, one thing we do know from studying the brain over and over again is that when we spend a lot of time with one particular mental task, the neural circuits that control that task will be strengthened. On the other hand, if we avoid certain mental experiences or tasks, the neural circuits controlling those tasks will be weakened. And this is an important point if we think about young brains, the young, malleable, especially plastic young brain as it's developing. We know that young people are very good at learning languages or learning musical instruments, but the frontal lobe, the thinking brain, is not fully developed. I know this from personal experience. I have 2 teenagers. One of them just went off to college, but I remember teaching my daughter to drive. And 6 months before I taught her to drive, I had jet black hair. I mean, it was just it was anxiety provoking. It was, look out for that car, whatever, Dad, you know. So the idea that the car is coming and we're going and putting that together, that complex reasoning is not quite fit in, and it kind of raises questions whether teenagers are the best people to have on the road. Now, another downside of being an adolescent is that the amygdala, or the emotional part of the brain, is not fully developed. So we know that from multiple experiments looking at empathy, the ability to understand another person's emotional point of view, that middle-aged people are much better at that than a teenager. So, you know, we're always hearing about the downside of the aging brain. There's an upside. We know complex reasoning is better, thinking brain and also the emotional brain. Now, another thing that's going on is the brain